Hey folks, it's Mr. Williams. This video's topic is multiplication of functions. Again, this is something that you did in Algebra 2. We are reviewing it in PreCal at the beginning of the year. So let's get started. I want to mention something that I also mentioned in the last video when we were talking about adding and subtracting functions and kind of expand on it a little bit. This right here, f of x times g of x with the dot right there, equals this right here, f times g of x. These are the same thing in PreCal. Once you start doing calculus with them, they can be a little bit different, but we don't care about that right now. But you do need to know that it is important that that is a dot and not a circle. This and this are not the same. Hopefully you can see from that distance. This is a dot, this is a circle. Those are not equal to one another, not equal. They are not the same thing. This with the dot is what you have done in the past, what you did in Algebra 2 that I'm about to do. This is composition of functions, which we'll get to in a few weeks. Okay, so we are doing this multiplication of functions. Okay, we are going to find g times h of x. Okay, g times h of x. I'm going to show you the way that we taught y'all in Algebra 2 last year, and then I'm also going to show you a shortcut way. So if you get to the end of what we did in Algebra 2 last year and you're fine and you don't want to know the shortcut way, that's fine. You can just end the video there. So we're going to take these functions, g and h, we are going to multiply them. The goal is to multiply every term times every other term. Okay, so remember, terms are separated by pluses and minuses. So this is a term, 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 this is a term. So we want to multiply every term in this function by every term in this function. It's kind of hard to keep straight, so there is a method that we teach our students to do it. We are going to take function g, we are going to write it down from left to right. Just like in the video over adding and subtracting functions, this is easiest if you use placeholders. So just like in that last video where I was missing the exponent of a 1, I went exponent of 4, exponent of 3, exponent of 2, and this is an exponent of 0. Remember, if it doesn't have a variable, I skipped an exponent of 1, so I'm putting that, that placeholder there. And then function h, the other function, I'm going to write this over to the left. I'm going to write it straight down. I'm going to make a box out of this. Okay? And I want to stress that this box is not math per se, it's organization. It's organization to help us keep straight what we're doing when it comes to math. Okay? We are going to multiply this row times every column. So we're going to do 2 times negative 2 is negative 4. X squared times x to the 4th. Remember, when you multiply variables, you add exponents to get x to the 6th. 2 times 9 is 18. X to the 2nd times x to the 3rd. Remember, when you multiply variables, you add exponents. So we get 5. I'm going to keep on going through this and just go very quickly. Remember, this is x to the 0, so x to the 0 times x to the 2nd, add those exponents to get a 2. Remember that this minus 5x, that's 5x to the 1st. Okay, so we can do 1 plus 4 for our exponents. X squared minus 5 halves x. Keep going, and you can hopefully see where I'm getting this stuff from. I'm multiplying the coefficients, the numbers in front, and I'm multiplying the variables as well, but when you multiply variables and the variable is the same, the way you do it is adding the exponents. Okay, so I want to, now that I've done this, I should have done my setup first. I forgot because I'm forgetful like that. So I'm going to go ahead and come over here to the side and do my setup that I should have done first. And I'm not making the video again because I've already had bad luck with technology today. So g times h of x equals, I'm going to put my first function in parentheses, negative 2x to the fourth plus 9x to the third minus 1/3 x squared plus 1/2. And then I'm just going to put beside it in parentheses the second function. Now you're going to notice we're going to run out of space here. Okay, so here's what I'm going to do. Anytime you have a plus or a minus, you can break this with an ellipsis, dot, dot, dot. Okay, and the way you come down here is you come down after that equal sign, you line it up. After the equal sign, you put another ellipsis, and then you keep on going with that plus or minus. Okay, and close parentheses. Okay, so all we're doing is we're going to another line since we ran out of room. I could have written it down there, it would have been fine. So we need to take this and get our actual answer from this. I'll tell you what it's going to look like in just a second. First of all, notation. We need to say g times h of x equals, notice those equal signs are still lined up. Okay. What I'm going to do for my answer, as long as you use this placeholder, your like terms that you're going to add or subtract are all going to line up in diagonals. Okay, so when we're combining those like terms, by adding or subtracting, we're going to combine the diagonals. Okay, so we've got minus 4x to the sixth, or negative 4x to the sixth. 10 plus 18, we get 28. Remember, these are like terms. When you're combining like terms, the exponents stay the same. Negative 2 minus 45 is negative 47. Minus 2/3, that was not a smart thing for me to do. Let's see, 150, 149, 140, 143. So minus 143 over 3 x to the fourth. Check and make sure that's right. 47. Yeah. And then combine these, which is easier. We get 32/3 x to the third ellipsis, because we're breaking at the plus or the minus, okay, because we ran out of space. After the equal sign, ellipsis. Keep on combining with plus 5/3 x squared minus 5/2 x plus 1/2. So, yes, it took me a minute to do those fractions, sorry. So first thing we need to do is set this up. I forgot to do that first. As long as it is done, you can go back and do it if you need to. Set it up with your question, the function notation that you're looking for, equals, and all of this. I broke at the ellipsis. I broke at the plus or minus by using an ellipsis, okay? I lined up the function going left to right. It does not matter which one is on the top and which one is on the side. It does not matter at all. I used my placeholder because that makes my like terms line up, okay? Multiplied the coefficients, multiplied the variables, and the way I do that is add the exponents. Okay, did all that, combined my diagonals since that's where the like terms were. Remember, when you're combining these diagonals, these are like terms, so you're adding or subtracting the coefficients. The exponents stay the same, so this does not become 28x to the 10th. You're not adding those 5s. It's just 28x to the 5th. Function notation equals all the answers. At this point, if you don't want to see the slightly shorter way, then you can turn it off. If you want to see the slightly shorter way, keep on watching. So this is slightly shorter for this one. For some of our questions, it's going to end up being quite a bit shorter if we have a bunch of exponents missing. You can actually, instead of putting that placeholder, just not put a placeholder. Okay. Everything will end up coming out the same, except your like terms will not necessarily be in diagonals. You're going to have to search for them. Okay? So if I do this, I'm going to get 1x squared minus 5/2 x and 1/2. Now you'll notice on this that this x squared is not in a diagonal with this x squared, okay? Because I didn't put the placeholder. That's what the placeholders do, is they make the diagonals line up. It's okay if you don't use placeholders, but you have to actually search for the like terms and say, okay, there's not another exponent of a 6, so there's not something to combine it with. There's not another exponent of a, there is another exponent of a 5, so I can combine those. There's 3 exponents of 4, so I can combine those. Add or subtract the coefficients, exponent stays the same. These are 3's for an exponent. This is not a 3, so I cannot combine them. I can only combine these two. This is a 2 for an exponent. This is a 2 for an exponent, so I can combine them. 1 for an exponent by itself and 0 for an exponent. If you think that makes it more confusing, ignore it. Only use it if it helps you. But if you had something where, for instance, there would be 3 placeholders in a question, it might be easier to just omit the placeholders and search for the like terms. So that's multiplication of functions. Till next time, be well, do good.